Welcome. In today's class, we are looking at the topic atomic structure. And in the course of doing this, we only consider shells of the atom for this very video. We know that an atom is the smallest particle of an element that can take part in a chemical reaction. Okay, an atom, or the atom generally, has two parts: the nucleus, which is the center, and then the shells. So the atom has two parts: the nucleus, which is the center, and then the shells. We were also taught that the atom has three fundamental particles, which are the protons, the electrons, and then the neutrons. So these are the three fundamental particles that make up the atom: protons, electrons, and neutrons. Protons are positively charged particles. Electrons are negatively charged particles, while the neutrons are chargeless. As I said, they are neither positive or negatively charged. Okay, the protons and the neutrons are found in the nucleus. The protons and the neutrons are found in the nucleus of the atom. Okay, remember I've said protons are positively charged while neutrons are chargeless. So if we have the protons and the neutrons in the nucleus of the atom, then it simply means the charge on the nucleus of the atom is positive. Why? Because protons are positively charged, neutrons are chargeless, and then we have these two particles in the nucleus. So that's why the nucleus of an atom carry positive charge. While the electrons revolve around the nucleus, along the imaginary parts called as shells. Okay, so electrons revolve around the nucleus of the atom along the imaginary parts called as shells. So these represent the shells, the different shells of the atom. The shells are lettered K, L, M, N, etc. and etc. And of course, they are also numbered: 1, 2, 3, 4, etc. and etc. And this numbering corresponds to what we call as the energy level. So by this we simply mean the energy level of the K shell is 1. The energy level of the L shell is 2. The energy level of the M shell is 3, while that of the N shell is 4. Okay, we can also refer to this energy level as the principal quantum number. The energy of K shell is the least, while those of L, M, N increases progressively as we move outward from the atom. Okay, now each of these shell has a maximum capacity of accommodating electrons. remember we said that the electrons are found in the shells of the atom. So each of these shells, they have their different tendency of accommodating electrons, and the maximum number of electrons in a shell is given by the formula 2n squared. So we use this formula to ascertain the number of electrons, the maximum number of electrons that can enter into the different shells, 2n squared, where n represents the shell number, that's the energy level or the principal quantum number. So let's now use this formula and then see the total number of electrons that can enter into each of these shells. So we start with the first shell, K. Now the shell number for K is 1. The energy level of K is 1, or the principal quantum number of K is 1. So if we substitute 1 into this, that will give us 2 times 1. The shell number is 1 for K squared. 1 squared is 1 times 1, which is 1. So that gives us 2 times 1, and 2 times 1 is 2. So this is to say the maximum number of electrons that can enter into the K shell is 2. Okay, so we write 2 electrons. The maximum number of electrons that can enter into K shell is 2. So K shell can accommodate 1 electron, it can accommodate 2. It will not accommodate more than 2. Let's see what will happen for the L shell. The quantum number, the principal quantum number or energy level of L shell is 2. So if we substitute, that will give us 2 times 2 squared. 2 squared is 2 times 2, and that gives us 4. So that will give us 2 times 4, and 2 times 4 is 8. So the maximum number of electrons that can enter into the L shell is 8. We write 8. We move to the M shell. For the M shell, the energy level of M shell is 3. So by substitution into our formula, that will give us 2 times 3 squared. 2 times 3 squared. 3 squared is 3 times 3, and 3 times 3 gives us 9. So this will give us 2 times 9, and 2 times 9 is 18. Therefore, the maximum number of electrons that M shell can accommodate is 18. So we write 18. And then the last shell under consideration, the N shell with energy level 4. So if we substitute, that will give us 2 times 4 squared. 4 squared is 4 times 4, which gives us 16. That will give us 2 times 16, and 2 times 16 gives us 32. So the maximum number of electrons that can enter into the N shell is 32. Okay? So we have that. I started by telling us that the shells of the atom are lettered. We have K, L, M, and N, corresponding to the energy level 1, 2, 3, 4, etc. and etc. And I also told us that each of these shells have their specific capacity of accommodating electrons. Now the formula that we can use to determine the maximum number of electrons that can enter into each of these shells is given as 2n squared. distribution, we have it that the maximum number of electrons that can enter into the K shell is 2. L is 8, M is 18, and N is 32. We've come to the end of our class today. Do ensure to like, comment, and share. And if you are coming across my video for the very first time, I encourage you to hit the subscription